In a previous video, we talked about specific heat capacity, the amount of energy you need to increase the temperature of 1 kilogram of a substance by 1 degree Celsius. In another video, we talked about how the internal energy of a substance is made up of the kinetic energy of the particles and the potential energy between the particles. The kinetic energy of the particles is related to the temperature, so this is related to the specific heat capacity, but the potential energy between the particles is related to its state of matter, solid, liquid, or gas. So the amount of energy you need to change the temperature, the kinetic energy of the particles, is to do with the specific heat capacity. Specific latent heat is to do with the potential energy. Specific latent heat is the amount of energy you need to change the state of 1 kilogram of a substance. We can tie all of this together by having a look at this graph here. This is a graph of heating a block of ice. We can see that we've got energy along the x-axis and we've got the temperature of it along the y-axis. Now I can see at first, as the energy increases, the temperature of the block of ice goes up. It goes from -15 to 0 degrees. Here, the heat energy is going into the kinetic energy of the particles. We could work out the specific heat capacity of the ice, all of this stuff. When the ice gets to 0 degrees, it stops increasing in temperature. You can see that as the energy increases, now the temperature is remaining constant. So if the temperature is not increasing, that means the kinetic energy of the particles isn't changing. That means the potential energy between the particles must be changing. So obviously what's happening here is it's changing state. The ice is melting. And that means we could calculate the specific latent heat at this point. Now, after all of the ice has melted, the water starts increasing in temperature again. The kinetic energy of the particles is increasing, the temperature is going up. We could work out a specific heat capacity of water at this point. Then the water gets to 100 degrees and suddenly it stops increasing in temperature again. We're no longer increasing the kinetic energy of the particles, we must be increasing the potential energy between the particles. So at this point, we're changing state again. We could calculate another specific latent heat because all of that energy is going into the potential energy between the particles, pulling them apart, turning the liquid into a gas. Once we go beyond this point, you can see that the substance once again starts increasing in temperature. We could calculate a specific heat capacity, the kinetic energy of the particles is increasing, and so on. So this graph might seem very, very complicated, but actually once you understand the basics of internal energy, kinetic and potential energy, specific heat capacity, specific latent heat, changes in state, changes in temperature, it's a really, really wonderful graph that sums up loads and loads of different ideas in physics all in one neat little place. And if you do have a true understanding of it, it's quite easy to remember what's going on. And if you don't, just rewatch this video a couple of times. All right, I hope this helped. And for those of you doing your GCSEs at the moment, good luck.